Hi, my name's Andrew and I've nearly completed putting an Ls1 into a 1977 Triumph Stag. A lot of work's gone into this, and during the process I've done a heap of design work, 3D printing and custom parts to bring my Stag up to the next level. This video is just a little bit about that journey and some of the work I've done and how I've approached those 3D printing and design parts of things. It also shows you a bit of an evolution from when I got the car to where it is now. I've been so inspired by this journey that I'm launching my own business called Bespoke 3D Creations, providing design and 3D printing services for other people too. So for me, growing up, the car I aspired to get that I could actually realistically afford was a Triumph Stag. Now I'm pretty aware of the build reputation and the quality and all that sort of stuff, so I always aspired to maybe doing a bit of a resto mod project. Commonly, an engine swap for that is a Rover V8. I bought mine with an Australian variant which was a 4.4 litre V8 that was based on the Rover out of a Ls1 P76. It was looking pretty tired and needed a rebuild. An engineer in Canberra told me, don't bother rebuilding that, chuck in an Ls1 that's pretty mild and you'll be right. And that's exactly what I did. This first clip is of the Ls1 P76 variant of my Stag, running so you can hear what the old engine sounded like. Just a few things to go. So that's all. Ls1's in, new radiator, air conditioning. We've got a full Holly front end for the Ls1. A temporary cover just over the front of the throttle body. I've currently got a cold air intake system in development, and that will feed around the outside here, over the alternator and down into the this space here. So we're going to be extracting cold air from down below with a bit of a scoop. The air conditioning gubbins, which are not currently plugged in inside the cabin, are going to be moved to the far side where the battery used to be, down there, to free up space, and that'll be one of the new vintage air conditioner systems. You can see the updated radiator with 2 fans there. I can't get under the car at the moment, but you can see we've got all new bits and pieces. The header will be ceramic coated. It's not, unfortunately, at this point, it's not a proper tuned pipe or extractors, just because of space. It's just really cramped. But we'll be looking at, down the track I might look at things, but look, it flows fine. I'm not looking for mega ridiculous power, and the way we've been set up is they could have moved the engine further back, but then you wouldn't get access to the transmission. So the engine sits slightly more forward than some cars we've seen that have done this conversion, but it means you can drop the transmission without needing to basically remove the engine. For those of you asking, we have the brake booster has been rebuilt with all new internals, produces a bunch more power. Yeah, so that's that, and I have a Holly Terminator X Max, which also controls the transmission gear changes. Full custom exhaust, handmade custom exhaust. The boot is a work in progress because we put the battery in the boot. So at the moment, we have an old aftermarket AC unit instead of a parcel shelf. That's getting removed and the parcel shelf being put back in. And under the new carpet, we have all the Holly stuff. That's all going to be moved into the parcel shelf, which will then mean I can glue down and clean up all the carpet and the wires. This is currently, my Terminator X Max is currently just out, so I can monitor how things are going. And this cable running up to here, again, temporary location, is the speedo conversion from the new transmission so that the speedo works. Let's start her up. You can see the engine doing its thing. The revs will drop pretty soon. Sounds pretty good. All going nicely. So it's got a lumpy cam. It's not a rough idle. The Ls1 has actually been cammed with a mild cam. So we get that little rough burble. It's not exactly original, but when I got the car, it wasn't original when I bought it. Here we are with the lights. So it's daytime, brand new lights are working nicely. No modifications to the bonnet. So it's all tight, but she fits. Sorry about the finger over the screen. So absolutely no issues with the fitment. And you can see again. So with the engine installed, the big problem we had was, well, the next consideration was some form of cold air intake or filter, because obviously, as you can see in the picture, we just had mesh over the end to protect any major things going in, but not enough room for a filter. So I was proposing that down the bottom left of the picture, where the AC stuff is, as I mentioned in the video, that we put a cold air intake system there with a K&N high flow pod filter. So to test the dimensions, I got the dimensions of a K&N pod filter, and I did a really simple 3D print. It's very light, not a lot of material in that, and a couple of bucks at most, if even maybe not even that in terms of material, just to see if it would fit. And fortunately, it looked like it was going to be a good fit, and so we decided to push ahead. So the next step for me was really to get a right angle elbow joint and to create a funnel to go from the throttle body to where ultimately the cold air intake housing would be. But it had to clear, as you can see here, the alternator. So airflow was important, but secondary to not modifying the actual look of the car. The other thing I have done, which you can just sort of see through there, is I 3D printed in a rib that runs down the length of the thing, because as it narrows, I was worried that under acceleration, the force of the engine sucking the air through could collapse the plastic because it's not a particularly strong shape. However, now it's very strong and that's not going anyway. So I designed this originally in 3D modeling software, but I've since rebuilt it in CAD. This is my CAD model using the free version of Fusion 360. And you can see the rib going through. I've beveled the edges to try and smooth it as much as I could. The other thing that I added, so the mechanic who's working on this at the moment suggested we get the MAF filter or plug set up into the air filter as close as possible to the throttle body. So we'll test that. If it doesn't work that great, I'll print a new one and we'll adjust the location of the MAF sensor. Obviously, again, the rib in the middle may cause problems or interfere with the sensor. So we'll see how it goes. Worst case, we'll go to a MAFless tune, but at the moment, we're giving it a crack. And when I do a dyno tune on it, yeah, we'll just see how it goes. But so the next step for me was really to try and build the cold air intake. And I needed a custom intake, obviously. I wanted it fully enclosed. And my options were pay someone else to fabricate something in stainless steel or aluminium or whatever, or do it myself. So I bought, to make it visible as an early Christmas gift, a Creality Otter Light scanner. And the reason I got an Otter Light was it was the top of my budget, but it was portable, or is portable. So you can use it either plugged into the computer, or you can have it connected to a phone or a tablet or whatever. So you can actually take it out and about with you to scan. And as my car was at the mechanics and I had aspirations of scanning all sorts of different things, I grabbed the Otter Light, and I must say, really loved it. So the handle and the Creality Otter Light itself has been really good. I highly recommend it. Obviously, the more you spend, the better quality you get, the faster it is, the higher the resolution. But for the money, to have the portability, I was absolutely blown away with it. Really happy. Does the job for me. So this is one of the scans that I took of the engine bay, and you can see obviously the little funnel or tube connector to the throttle body's plugged in. That's the top of the Ls1. Got a pretty good scan. It's not super duper detailed, but you can, there's enough there for me to build from pretty accurately. And one thing I will add, the main cold air intake point that we have settled on, and I'll put the texture on so you can see this. So this is with the texture. So there's a hole at the bottom here. That's a minor intake. So I've got a hole and a little funnel that sits in there to draw some of the cold air through. But this section, all through here, this sort of rectangular or square panel, is just tack welded in. And there's a massive space behind it where the horn is. We're just going to replace or move the horn to a different location and remove that whole panel. So there's a big square space that just goes through to the front of the car, basically, with pretty good airflow. And also on the side here, you can see there's a little bit of a cutout too into the side panel of the car. So there's 3 points of ingress for air, with the main one being at the front, but a little bit extra on each side. And I've tried to design something that would draw as much air as possible, just as far away from the headers as possible, and also avoiding, originally I was thinking of having a funnel go down into this section of the car here underneath the radiator, but obviously if it was raining, or if there's dirt, stones, dust, whatever, if I go through a puddle, it's just going to be sucking all of that dirt and mud and crap up into the cold air system. So and where it'll also get really cold close to the radiator and the exhaust as it bends around, and we're putting in the catalytic converters, the CATs, just around there too. So there wouldn't be a lot of room, there'd be a lot of heat, radiant heat there, and the risks of sucking stuff up. So that's why we've gone for removing this square, secondary there, and also here. And just removing and realigning some of these other bits and pieces. So here's the CAD design I created. You can see that it's tailored to the shape of the wheel arch, and there's a bolt hole here, here, and here. So 3 bolt holes, which I've reinforced with additional material.
that's aligned to a few existing bolts with one extra hole that we're going to need to remake. Because of the shape, it'll sit down nice and snug on the wheel arch. It's pretty accurate, but I'm still putting in a thin sheet of foam or high temperature rubber just between the wheel arch and the plastic on the 3D print to stop vibrations and noise. That is also printed in PAHT, which is a form of nylon with carbon fibre in it. It's a high temperature material, allegedly able to resist temperatures of about 190 Celsius. I've also ceramic coated the headers, so that should help reduce the radiant heat from them. And if we look here, you can see where the headers are and why I've created this arc or this sort of curved shape, so that we reduce the contact or the increase the space. You can also see this section here is where the cutout's going to be and the main draw of air is coming from, and this little hole in the bottom is that base section. And while the lid will be on, put the lid on, it sits here. This little cutout on the side is away from the engine, but just allows a little bit of extra air to come in from that side channel. Again, maximizing the cooler air and airflow as possible, and making the most of what holes and things are already there. I've test fitted this. It just fits really snug and really nice. And as I said, I 3D printed it in PAHT CF, which came out pretty good. So this is image of the final version. As you can see, that's a carbon fibre filament, which has a bit more of a matte and grainy texture. I quite like it. This is as an example of it just here. I don't mind it. It feels, it's pretty strong. It's a bit more brittle, but it's really dense and solid. And the top funnel is printed, which is this shape. I've done that in ASA. ASA is good for around about 100 degrees centigrade, so it's far enough away from major heat sources that it should be okay. It's a smoother material. There's no chance of, or less chance of, fine particles or anything going into the engine bay. And it's a bit lighter, so hopefully that works all right. Anyway, you can see it from another angle where it's screwed down. I used heat set inserts for the screws so that it's nice and solid. It's a pretty snug fit. Obviously, it's made specifically to fit. You can see where there's a very small gap, and that's where the silicone is going to go. And all in all, I'm pretty happy with how it turned out. Thanks for watching. There'll be more videos coming soon about other work I've done on the Stag. I'll also be doing videos on work I do for other clients, showing all sorts of different projects. Please leave a comment, let me know what you think of the video, and if there's anything else you'd like me to delve into in future videos. Subscribe and have a great day.